Welcome back, students. We're going to be talking about integers and rational numbers and comparing positive and negative. So you're going to be categorizing them and also plotting them on a graph and knowing which one's larger, which one's smaller. So the first category we have in the book is whole numbers. But if you actually start with a whole category, I would say the natural numbers. And this is also viewed as the counting numbers, is the smallest category. Now this category is going to start with 1, 2, 3, and so on. Okay, then we have whole numbers. And whole numbers, in this case, will be every number that's not negative. So we add 0 to it, okay? The next part is integers, okay? Integers are going to be the whole numbers and their opposites. So opposites are the negatives. So you have dot, dot, dot. So we start with 0 in the middle. We go -1, 1, -2, 2, and so on, okay? So integers are actually going to be larger, in a sense, than the categories above them, because you have infinitely many going this way, infinitely many going this way. Now the category that's infinitely larger than integers is rational numbers, okay? And there's a key definition that you need to get. So rational numbers, so this is integers, whole numbers, natural numbers, rational numbers. Rational numbers are written A over B, where A and B are integers, and B is not equal to 0, okay? Now, irrational has several definitions. But basically, the best way of saying it is that it cannot be written as a A over B. So it cannot be written this way, okay? So rational numbers can be written as a fraction, whereas irrational cannot. Finally, this one grows in size, and then this one grows in size, which would imply that this one, real numbers, is going to be all rational and irrational numbers. Okay? So that's going to be real numbers, okay? So categorizing something. If something is a whole number by nature, if it's a whole number, then it's an integer, a rational, and a real, okay? Irrational can't be written this way. So this is going to be a unique category, okay? Right here, this is unique, okay? Now, let's look at some examples. -3, what can it be written as? Okay, so that's not a whole number. Is that an integer? Yep. So that means that's rational. Yep. Is that irrational? No. So this would be a real, rational, and an integer. Okay? I go from big to small, meaning you start with the biggest category and go smaller. You could start with small and go big. So you could say integer, rational, and real. But once you say it's an integer, you don't really need to say the other two. Okay? Okay, what about, let's get another example. What about -2/2? So this would not be an integer. this would definitely be rational. So this is a real number, then it's rational, and that would be it, okay? And that's it. That's our definition, okay? So this is a way of categorizing these, and then let's go on to the next part, okay? So we categorize them. Irrational, a good example of an irrational number is the square root of 2, or pi, or e, or the square root of 3, right? A number that the decimal doesn't repeat. It's a non-repeating decimal, okay? The way they say it is it's an infinite decimal, but it's non-repeating, because repeating decimal actually is going to be a rational number, okay? Okay, so comparing positives and negatives in the book, we're just looking at the book for a second. They comparing on graph which one's larger, kind of knowing which one's greater, classifying, that's what we just covered. And so let's get to here. Ordering numbers. So ordering from least to greatest, remember we go from more negative to less. So we start with -2, then -1.2, then 0, 3, okay? So remember, and with fractions you actually sometimes need to check which fraction or decimal is larger, but in this case these are clear, okay? Opposites. So an opposite is just attaching a negative to something. So let's say you have -3. What's the opposite of -3? Well, let's put a negative there. What happens? That would be +3. So 3 is opposite of -3. Okay? These two are opposites, okay? Now, the best way of looking at this is opposites on a number line are going to be the same distance from 0. So if I have 0 in the middle, and I choose something like 4, what's the opposite? Well, I have to go for the opposite direction, -4. Okay, so these are opposites. And a crucial idea is that if you have the absolute value of a number, either negative or positive, it will always generate a positive because it's telling you the distance between that number and 0. So it's like 4, okay, 1, 2, 3, 4. Okay, it's 4 spaces. That's going to be our absolute value. Same thing for positive, it's going to also be a positive, right? For distance, 1, 2, 3, 4. Okay, so the absolute value of a positive is a positive. The absolute value of the negative is also going to be the positive, okay? Or like the book says, it's going to be the opposite, okay? Now, we're not going to cover conditional statements, but for extra credit, I will let you do that. Consider learning conditional statements, okay? That's going to be it for this lesson. So this lesson is pretty brief. We will cover comparing stuff and talking about that. Conditional statements are useful. If, then, hypothesis, conclusion. So if something's true, then something's also true. But if it's not true, there's a counterexample. Okay? This is useful in math and actually in several other fields. Okay? Thank you so much for joining. This is a very short day. So enjoy this Friday. Thank you so much. I will see you soon.